Welcome to A-Level and AP Physics, a place where you can improve your understanding of physics with confidence. In today's class, we will talk about quantum physics from Cambridge A2. We have already done two videos on this topic and this is third one. For the previous two videos, you can go back to the channel and you can search for part 1 and part 2. In today's lesson, we will discuss what is photon, how to calculate energy of a photon, and how to calculate number of photons in a beam of light. Part A is simply asking us what is meant by a photon, and this is very common question from quantum physics, or I can simply say it's a kind of typical question from this topic. And total number of marks for this question are 2, and most of the time student they will just get 1 mark because they don't understand how to define in a proper way or how to write a proper answer for this question. Let me explain to you how you can write a proper answer to get 2 marks. Here is a full answer. If you write your answer like this and you mention these 2 points, first point is if you have mentioned discrete amount of energy, you will get 1 mark. And if you have mentioned about electromagnetic radiation, you will also get second mark. For part B1, simply we need to show that photon of light has energy equal to this. And let's see what is given to us about light. And about light, it is given to us that it has wavelength that is equal to 570 nanometers. Now what we need to find out, we need to find energy of photon, and we simply understand energy of photon, this is equal to h times f. F is the frequency of light, and because frequency of light is not given to us, so we need to convert this one into wavelength. So simply we understand frequency is equal to c over lambda. Now in this case, h is a Planck's constant and c is also constant, that is equal to speed of light, and lambda is given. Simply we need to plug in values and we can find out energy of a single photon. So this is how we can calculate. So in this case, simply you can see I have just plug in given values and I have done these calculations. And if you plug in lambda, so this is value of wavelength of light, and here is energy of photon in joules. You have to be little clear about this one because this is given in nanometers, so we have to convert this one into meters. If we convert into meters, our final answer will be in joules. For part B2, it is given to us that time is equal to 1.0 second, and this part is further subdivided into two parts, part 1 and part 2. It is very easy to understand for many students that the time for part 1 is equal to 1.0 second. But when students they go to part 2, they just don't know what is time. But we need to understand in this case time given for part 1 and part 2 is the same. Means all calculations for part B2 are based on t is equal to 1.0 second. This is very simple point, but most of the time this is just overlooked by many students. And so this is one thing we need to understand. Now let's try to answer this question. Now part 1 is simply asking us, we need to find out number of photons incident on the surface in 1 second. So if we read question carefully, if we go back, it is given to us that the power is equal to this 2.7 times 10 to minus 3 watts. So another way of writing this one is that is equal to 2.7 times 10 to minus 3 joules per second. Means the amount of energy incident on the surface in 1 second is equal to this one, and this is the total energy of beam arriving this surface in 1 second. And in part B1, we have already calculated energy of single photon. So now we need to use these two informations and we need to calculate number of photons. Let's try to answer this now. So if you look at this one, I have already done these calculations. So concept is very simple. First thing you need to understand, what is power? So power is rate of transfer of energy. So how we can calculate number of photons? Simply we need total energy arriving the surface in 1 second, means the total energy of beam arriving the surface in 1 second. So and we simply need to divide by energy of one photon. So we have total energy, we also have energy of single photon. We simply need to divide and we can calculate total number of photons. So here are total number of photons. For second part, simply we need to calculate change in momentum of the photons. But if we read question carefully, in the previous part it is given to us that the light is absorbed by the surface and light does not reflect back. So it simply means that final momentum is equal to 0. Now as we need to calculate the change in momentum, so we understand E is equal to mc square. We can little bit rearrange this one. So this is the momentum, means mass time velocity. So we can say E is equal to pc, or we can say the momentum is equal to E divided by c. So here this is momentum of a photon. E is equal to hf, so we can say this is hf over c, and this is equal to momentum of photon. And f over c, we simply understand this is equal to 1 over lambda. So we can say momentum of a photon, that is simply equal to h over lambda. So here you can see we have just plug in value of h. H is Planck's constant, and this is value of lambda of light. And if we just solve it, we can find momentum of single photon. But in this case, the number of photons arriving the surface, they are equal to this. And we need to find the total change in momentum. So we just need to multiply number of photons with momentum of single photon. So this is the final answer, mean this is the change in momentum. For part C, simply we need to use our answer in B2 and we need to calculate pressure exerted by the light on the metal surface. Pressure, we simply understand this is equal to force over contact area, or simply we can say over area. So force also we understand that is equal to rate of change of momentum. We can say simply delta P over delta T. And delta P over delta T we have already calculated in part B2. So it simply means that we need to divide part B2 by area of the surface and we will be able to find pressure. So as you can see here, first of all, I have written that pressure is equal to force over area, and then force we can say is equal to change in momentum per unit time, and then we have to divide by area. And this is our answer from part B2. We simply divide it by contact area, and this is our final answer.